distance, which is independence of materials, colors, and brightness. Whereas the high resolution output, which is provided by the laser distance, is to provide position or displacement, usually to the input of some type of industrial controller. So we'll have several types of laser distance sensors, which include diffuse, background suppressions, and retroreflectives. So these sensors use CMOS or transfer time technology. And similarly, the laser light must be focused and it must stay narrow over a great distance and spare the spectrum. The emitted light can be triangulated or pulsed, with each pulse returned to create a laser sensors. According to the measurement principle, the principles of laser distance sensor is divided into two methods. One to be the laser triangulation and other to be the echo analysis. Whereas the laser triangulation method is suitable for high precision and short distance measurement, whereas the case of laser echo analysis is used for long distance measurement. So this is the block diagram or the transmitting diagram for the laser sensors. So whereas we'll have a visible red sensor to the object surface through the lens, which is reflected by the object passes through the receiver lens, as well as the internal CCD. According to the different distances, the linear camera can see the light point at different angles. According to the distance between the laser and the camera known for the angle, the digital signal process can calculate distance between the sensor and the measured object. At the same time, the position of the beam in the receiving element is processed by analog and digital circuits, whereas the corresponding output value is calculated by microprocessor analysis. So if switching value output is used, it will be considered a set window. And in addition, independent action window can be set for analog quantity and switch quantity output. Whereas the laser distance sensor can achieve a certain degree of accuracy. The sensor are composed of processor unit, echo processing unit, laser transmitter, and laser receiver. So whereas it is also called as pulse time method, the laser echo analysis method is suitable for long distance detection, but the measurement accuracy is lower than the laser triangulation method, and the longest detection distance can reach up to 250 meters alone. What are all the parameters? So one thing to be the resolution, repeatability, full range, linear accuracy, sampling frequency or sampling period, average sampling times. So resolution, minimum range of sensor, there is a maximum recognition rate. Repeatability, if the measured object is stressed, the measured value will fluctuate slightly. What about the full range? It is the rated effective range of sensors. What about linear accuracy? They are between the measured value and the actual displacement. What about the sampling frequency? So actually the frequency refers to the number of measurements per second. Average sampling times to be the multiple measurements are required to calculate the average number of times. What about the advantage and disadvantage? Advantage is that they can resolve measurements less than 1 micron at reduced cost. Whereas the disadvantage, the laser systems are clean and free from dirt and other foreign materials. So otherwise accuracy will be affected. So that vacuum installations cannot be carried out sans external cooling. So whereas applications will have a position sensing, dynamic measurements, thickness and dimensional measurements. And MEMS sensors have to be low cost, high accuracy initial sensors. So they are used to serve an extensive range of industrial applications, namely micro electromechanical system. So they are used to detect as well as measure the external stimulus like pressure. After that, it responds to the pressure, which is measured pressure with the help of some mechanical actions. The best example is that MEMS IC fabrications. MEMS fabrications needs many techniques which are used to construct other semiconductor circuits like oxidation process, diffusion process, ion implantation process, low pressure chemical vapor deposition process, sputtering, etc. Whereas the working principle, it is still applied to the MEMS sensors, and a balanced mass makes a difference between the electric potential. This can be measured like a change within capacitance. Then the signal can be changed to create a stable output signal in digital 4 to 20 milliamperes or VDC. These sensors are fine solutions to some applications which do not demand the maximum accuracy like industrial automation, position control, roll and pitch measurement, and platform leveling. The advantage and disadvantages are to be the power consumption is very low, simple to incorporate systems are changed, the thermal constant is small. These can be highly opposed to shock, radiation, and vibrations. Better thermal development tolerance. So we'll have a parallelism. The main disadvantage of this sensor is even though the making cost for each product is extremely low, but there is a huge investment associated while designing, manufacturing, and MEMS prior to work. Whereas the MEMS sensors are used in different domains which include automotive, consumer, industrial, military, biotechnology, space exploration and commercial purposes, which include inkjet printers, accelerometers within modern cars, consumer electronics in personal computers, etc. When they are saying about a nano sensors, actually the sensors are road detect cars at traffic lights and adjust the flow through intersections. Sensors at shopping mall detect your presence and open doors to allow you to enter. Sensors measures the water level in the washing machine and ensure it does not overflow. Nano sensors are platforms with the characteristic dimensions, nanometer in scale, and work in much the same way as sensors. They detect either minute particles or minuscule quantities of something. Nanosensors are chemical or mechanical sensors that can be used to detect the presence of chemical species and nanoparticles or monitor physical parameters such as temperatures on the nanoscale. They find use in medical diagnostic applications, food and water quality sensing, and other chemicals. Whereas in the case of a working principle, the thing is to be that the transducers and detectors are the main components of sensor system with the feedback from the detector to the sensors. Sensitivity, specificity, and ease of executions are the main goals in designing a sensors. Nanosensors typically work by monitoring electrical changes in sensor materials. For example, carbon nanotube-based sensors work in the nitrogen dioxide. Similarly, if ammonia is present, it reacts with water vapor. Nanosensors have been developed and applications which includes various chemicals, medical diagnostic purpose, in order to monitor physical parameters as accelerometers to monitor plant signaling to study the tactile sensor is a device which measures the coming information response to the physical information. Cutaneous touch has the capability of detecting the stimuli responsive from the mechanical stimulations, pain, and temperature. The kinesthetic touch receives sensor input from the receptors. The tactile sensors are developed to provide tactile sensing abilities for the daily operational manufacturers. So there are several three-dimensional sensors developed by using the piezoresistive, capacitive, and optional sensing elements. And these tactile sensors are fabricated by the EMS technology. One of the examples directly related to the planetary exploration. So NASA has tried many technical robotics which are used in the initial stage. Whereas in the case of an application, it is used in robotics, computer hardware, security systems, touchscreen devices, and mobile phone computing. Whereas advantage, it is easy to use tactile solutions. It has no external components and cables. It have a compact extraction, verified tactile sensing technology from robotics. So by that, the fourth unit gets over. Thank you all.